everybody, and thank you for joining us. Last couple of weeks, we've been looking at a patio that we're replacing, and whoever can guess the bid price of that patio, we're doing a cash giveaway. We're giving away $100 to whoever guesses the bid price. So far, nobody has guessed it. However, one person has come very close. So we're going to run this one more week, and whoever can guess the bid price of that patio, the $100 is yours to keep. We're going to run it one more week, so let's go ahead and place your final bets now. Meanwhile, in the office, I'm working on transcribing this information from this webinar that we did a few weeks back, or a couple months back now, actually, because we're putting a packet together. There's a lot of information to transcribe, so it's taken a little while to put it all together, but this is what I'm working on right now. We're in the phase of this webinar, which discusses assessing the feasibility of putting a basement beneath your house. So I'm not going to talk too much about that. I'm going to go ahead and let the video talk for itself because we have the recording of the webinar. So I'm going to go ahead and let that play. So if you've ever wondered what it would take to assess the feasibility of putting a basement beneath your home, go ahead and watch this video where we talk more about that, as far as all of the things that we look at, the steps that we take when we do a walkthrough, and how we bid that project.
There's actually some stress cracking that goes from this corner and it moves up along this side, and then there was some from this top window where it was cracking back in. So these are things that we're looking at when we're walking the exterior of a building to see what the foundation or the brick or the walls, what they're doing. Trying to see where they're at. And as you can see on this as well, is there's no access alongside of this house to either set a conveyor belt out this window to put dirt, because there's just no accessibility. You would have to put a conveyor belt there and then have a guy up here to wheelbarrow the dirt consistently all day long. He was telling me that there was some drainage. So on this, on this house, this neighbor has all of his downspouts coming down right here, and then they're pointing to the property. So all the water that comes from this property is actually draining and coming across the property line and going to the neighbor's house, which is causing him issues. Let's see, go a little bit farther. I think that's it on that one. What's that?
Yeah, let's see.
So when we're looking at that, that's a factor of effect for the cost accessibility when we're putting the bids together to do these jobs. So it makes it more difficult for us when there's no room for us to work on that exterior of the house to get the dirt. Unfortunately, I don't think we have real good pictures of the backyard on that one. So they have a garage structure and there's no gates on either side of that structure. So we would actually have to go through the garage into the alley with equipment. Right now, what we're doing is we're walking through the interior of the house, looking at the foundation, how the structure is being held up right now, looking at the integrity of the brick that has been here for, I think this house was built in, what was it, early 1900s?
Oh, I don't remember.
I think it was an early 1900 house. So if we go back here, let me take this back here a little bit. Oh, right in here. Let me see if we can So this brick, this picture is actually pretty blurry right now, but this brick on this exterior wall right now, the tuck pointing of the brick is starting to fail because there been so much moisture that has been coming through the wall. The tuck pointing is actually starting to fail. So that would include us before we could even do anything on this. We'd have to cover this entire exterior wall with probably either pouring a wall in front of it or shotcreting the wall in order, because you can see down here at the bottom of the screen, the brick's actually starting to decay. Over in this side, you can see the tuck pointing and the brick starting to decay as well. So that is a good indicator that moisture has been coming through. The brick integrity itself is just not there. So we need to do precautionary steps before we could even do a dig out in this basement.
So how would you, if you were to shotcrete that over that wall, how thick would you put your shotcrete? And would you put reinforcement in there, a vapor barrier, or how would you do that if you had to?
So if we had to shotcrete that wall, we would have to put dowels in the wall, and then we'd put a wire mesh over the entire thing. And then our shotcrete would be 3 to 4 inches thick.
Okay, so it's kind of like we did at the job in South Denver we're on right now, where we encased the existing foundation that's brick,
Correct.
and they put wire mesh over it and sprayed over it.
Yes. So when we run into these situations, I mean, it's better to take the precautionary, especially when a foundation is in this type of situation. It's in a bad spot as it is. So by adding the shotcrete to the brick before we even take the concrete out in the floor, we're tying everything back together, and then we're giving it a structurally sound spot. So if we took this floor out the way this house is right now, I could guarantee you that house would fall.
Huh.
So if we took the precautionary steps and added the shotcrete to the foundation walls before we did any demolition, then that's going to tie everything back together structurally so that we don't have to worry about it falling on us.
Gotcha.
We got any questions so far, or we
Hey,
good to
Thomas.
go?
Yes, there was just another question entered a couple minutes ago asking, when do you determine if it's more economical to either jack the house up and replace the foundation or extend the foundation down?
Can you repeat that?
Sure. It reads, when do you determine if it's more economical to either jack house up and replace the foundation or extending the foundation down?
So we've never actually jacked the house up to extend the foundation up. A lot of our work does go downwards. I mean, in another aspect, I mean, that's really on the client if they want to spend the money to go down, or if they would rather bulldoze a house and actually start from scratch. I mean, that's really a question for a client, because I mean, you just don't know how much money people have. I mean, they may want to take a house because of the location of it and demo the whole thing and rebuild just because of the area that the house is in. I mean, some clients may say, I don't want to spend any money on it, and move away from it. So that's really a determination from a client factor on it.
That is a good question though, because I've even asked Gold, why don't we do that? Just raise the houses up as opposed to, doing basement dig outs. Well, we would still do a partially dig out, but raise it up. And well, I mean, it's not something we do because we've never done that. We're not in that. It's a totally different process. So
So, I mean, another aspect that you'd have to look at too is the building envelope. Are you allowed to take an existing foundation and add, 4 or 5 feet and raise the house up 4 or 5 feet? Is it still inside the building envelope? A lot of the building envelopes that we're working in won't allow it because you already have a two-story house and they're at the max point of the building envelope. So it makes more sense to go down because you can't go up because they've already maxed that building envelope out. So a little bit more walking through this video here. Let's see if we can speed this thing around.
You could even just let it play if you
Just
want to have.
So at this point of the conversation in the video, I'm looking at what they have for the floor joists, what the floor joists are sitting on, what kind of beams they're what type of beams are carrying the load, and what condition the joists and the beams are in as well. So let's come through here a little bit more.
And she's not happy because of the cost, by the way, just a side note.
Yes.
If you're curious about the expression, that's why.
All right. So I'm going to start it again right here. We'll pause it here in a second. This goes back into what Rico was just saying. Yes, the client, the female side of the client, she was not happy. He was a little bit sticker shocked. And then we're going to get into what I was just explaining, the floor joists, the beams, how they're tied in there. So right here in this house, so up here they have roughly 6 2x10s spanning from end to end, and then they had a 4x4 post here that doesn't seem like it's very structurally sound. They have no ties on the floor joist. They have a single 2x4 running at the bottom that some of them have a gap, some of them are sitting on it. These boards are rotting and just decomposing, as you can see in this video. And I'll let it play a little bit more here. And as you've seen with the client's hand, I was explaining to him how the floor has a wave in it. And once we get up into a little later in this video into the next video, we can show you how the floor has moved because of the movement of the foundation as it is. So if I recall right, there was, what was it, 4 inches of difference between one side of the floor to the other side?
Yeah.
Or was it 6?
I think it was 4 inches.
So
yeah.
There was, so on one side of the basement, it was about 4 inches higher than the other side. And this here, we're still looking at all the floor joists and looking at the condition of them. I'm going to see if I can speed it up a little bit because
I have a question here. Could these same principles be applied to if this were just a crawl space? Like, are you looking at the same things? Your accessibility, well, obviously your accessibility, but other things like pressure, cracks, or things that you've explained during your walkthrough on here. Are those the same things that you would look at a a full, just a crawl space area?
that we're converting to a basement.
Yeah.
Yes, that is. It just makes it more difficult when you're doing the crawl spaces because you're in there crawling around on your stomach, you're laying on your back.
Right.
Because, I mean, a lot of these crawl spaces will go from, you know, 1.5 feet to maybe 2 feet of space in there. So you're in there crawling around instead of being able to walk around in an existing basement.
But you're still looking for the pressure cracks and the weak foundation, the weak point.
Correct.
Okay.
And if there's so in my determination on this one, this would be one that I would have to bring an engineer out and say, okay, do we need to put an LVL beam in here that is a triple, or would it make more sense to put an I-beam in here? Do we need to put a W30 I-beam in here, or what do we need to put in here? What exactly does the client want? Do they want to have an open span in this basement? So do we need to have a bigger steel beam in here so that we have we can make an open space in here without having more posts?
Huh, okay.
So yes, that does go into the same aspect for doing crawl spaces. It's just a little more difficult because you're crawling around in them instead of standing up, walking them.
Right, okay.
Hey, Thomas, I see another attendee question as well.
Okay.
This question reads, what is the square foot cost range for underpinning a crawl space foundation and creating a full basement?
Let's hold on
So-
1 second. Let me
All right.
see.
I can give you a breakdown on that.
Can you?
Yeah,
All right.
it is $280 to $350 a square foot. That's
Okay.
our-
So I would imagine a $280 per square foot dig out for a house would probably more likely be for a concrete foundation house that has an existing concrete foundation house. Is that my understanding? And
Yeah.
then one that would cost $350 would make more or less have a brick foundation or a stone foundation because of the more intense labor and work and the more details that you have to put in at the beginning of the project in order to do the dig out.
Yeah, that's the way Gold broke it down to me when we were talking about that cost, that price range. So if you can imagine the most difficult project as far as accessibility and everything else, then it would fall on the higher end of that range, closer to $350 a square foot. But if you have a house, like Tom was saying, that already has a solid foundation, maybe probably already even has a basement, and all we're doing is lowering that basement floor by a few feet, then it would be, more toward 280,000 or $280
A square foot.
a square foot.
I mean, we have to take in consideration how our accessibility is too on the outside of the house, on how hard it is to get the material out. I mean, what we seen earlier on this video as well is there was roughly 3 feet from fence to house on this job. So we would be spending more labor and manpower just to get the dirt out of the basement and into a trailer or a machine that's on the backside of the garage that we can't get machinery into. So that would go to the higher side of a project too, where if we can get a machine on the outside of the house and drop the dirt into the bucket or make a big pile where we're scooping it with the machine and loading it into a trailer, we're not using as much manpower. So those are things that we look at too when we're pricing those as well.
I think that's something a lot of people overlook, is that part of it, just moving the dirt out.
Right.
Like, how many trailers of dirt would you say have come out of the basement job we're on right now?
So I think that is, if I recall right, that's about 1,000 square foot basement. And One portion of it, we took it down 18 inches, and that section there, I believe we took out roughly 8 trailers of dirt. And then you get into the section of the basement where we're taking out 4 and 5 foot of dirt, and we've taken out roughly 45 to 50 trailers.
Huh. Okay, from that so altogether, what, like 60, 70 trailers of dirt?
Yes.
Okay, so I just want to break this down a little bit because this is something that a lot of people overlook. If you can imagine 60 loading up 60 trailers of dirt, because I've been out there on the job when we're having to squeeze into a small access point and we're pulling it out one wheelbarrow at a time. We can get maybe one trailer of dirt out that day, that whole day, maybe two. Maybe if we have another trailer right there waiting, and as soon as that one goes out, the other trailer pulls in, and the guy is just steady wheeling or taking turns with another guy wheeling dirt all day, maybe two tops. So imagine the cost of pulling out 60 to 70 trailers like that, 1 to 2 trailers at a time a day, as opposed to like what you're saying. We have a trailer backed up right up to the access point where we're pulling the dirt out from. Maybe it's coming right up on the conveyor belt
And right into the trailer.
dumping right into the trailer.
So let's break that down a little bit more. So if we're getting one trailer full of dirt, that is roughly 100 wheelbarrows of dirt. So if you're
Okay.
getting 100 wheelbarrows for one trailer, that is taking one guy to load that trailer roughly
A day.
half a day to 3/4 of a day, just running
Yeah.
dirt from the window well to the trailer. And then if you step it up a little bit more, it takes 5 trailers to fill one tandem dump truck.
Wow. Okay. Yeah. So
So one tandem dump truck is 15 tons of dirt, roughly 14 to 15.
So what would be the difference between if we're moving out a trailer or a wheelbarrow at a time, or, or if we have an open access point where we can either dump right into the trailer or dump into a pile that we can then load up with heavy equipment?
The difference would be if you're using a machine, you can get 2 to 3 times more dirt in the bucket than you can a wheelbarrow. So you're moving 2 to 3 times more of the dirt on the outside of the house, either into a trailer, or once you have a stockpile on the property, then you can use the machine to take that dirt and put it into a tandem axle dump truck.
So we're
So you're
talking
moving-
like 5 trailers a day as opposed to 1 trailer a day.
Correct.
Okay. All right. Yeah, so that gives us a good idea, a better idea of, that imagine the cost difference between moving out, being only able to move out 1 wheelbarrow at a time, as opposed to five trailers a day, 1 trailer a day or 5 trailers a day. It just has a huge impact on the cost.
Right. So, and that, I mean, those are sections of the job that we look at in order to see, are we on the low side? Are we in the middle? Are we on the high side? So that's where that varies from the $280 to $350 a square foot. I mean, if you can get a tandem axle truck in there every other day because you can stockpile dirt, that job's going to move easier and faster compared to a job where you're only getting 1 wheelbarrow out every 10 to 15 minutes. Does that answer your question?
Roughly, vaguely, roundabout, in a roundabout sort of way. Yes and no.
Yeah. All right. Moving on with this video.
This is a good visual here
Yeah,
for this. I didn't even think about putting a video on because I've never done one of these before. So
right. We're learning as we go.
yeah, yeah. What are we on right now on this agenda?
Adding basements to existing buildings.
Okay.
So once we get done with this video, we will move into a video that we walk through the upstairs, and we can get into that a little bit more, show you areas of the house that has actually moved, and some areas have raised and some areas have sunk. So, and that these walks and actually these videos they come in handy because we can actually come back to them and say, hey, did we miss something? Or did we need to add something else somewhere else that we didn't see at the time of the walk?
They just shut the door on us.
They did. They're locking us in our closet. No. All right, let's see if we can move this a little bit. It's going to get a little darker in this portion of the basement because they didn't have any lights in there. I'm actually looking for they had some broken floor joists and some pretty shoddy beams that were holding up this house that had made the house sink on this backside of this property. And I'm not sure if right there. Oh, see if I can. So this floor joist has a crack in it, and I tried to pause it fast enough where the light was on it, but it goes from here and then it starts opening up all the way through here, and then it comes through, opens up here. The floor joist isn't touching the plywood floor anymore here. This is all rotted, and then they tried to do a fix on the backside here, but in my opinion, they only brought the board to about here, and then it went to about here. And it's always been rule of thumb that if there's a crack here, you're going 4 foot this way with a splice and 4 foot this way.
Move the light back or the picture.
Let's
If
see.
you click on the circle there and then just press oh, not that one. Yeah, click on that and then let it go and then just touch the keypad on the forward. Yeah, right here. Here, hit this one right here.
Oh,
Is that the same one? Yeah, that's the previous frame there.
yep. So as you can see, it's a little bright and it's hard to see in here, but there's actually a very wide gap in between here. But as I was saying, it's rule of thumb that I've always known that if there's a crack here, you need to go 4 foot in this direction and 4 foot in this direction, which they had a piece that was roughly 2 foot long. It went from here to about here. And it just, to me, that's not structurally sound.
Oh, it's supposed to be spliced in either direction, 4 feet in either direction with another joist?
Correct.
Okay. Oh, there it went back.
And on top of it, they had a 2x4 right there that was barely hanging on to the beam. No hangers. Let's see here. Let's see if we can get through a little bit brighter. Doot, doot. And at this point in the time with the conversation with the client, I'm explaining to him what I was just talking to you guys about with the floor joists, the brokenness, having them spliced together right. If they wanted to splice them, if they wanted to take the joists out, replace them completely. Let's see, do we get into the upstairs on this one? So as I was saying earlier, this basement had, so on this side of the basement, it was roughly 4 to 5 inches higher than this side, which is back here on this behind us. This staircase is actually not up to code because as you come down the stairs, you almost whack your head on the upstairs floor joist that runs across the opening. And out here where we're at, we have to have at least 7'4" in order for it to meet code. That is another section of the foundation right here where my cursor's at, where this portion of the foundation has heaved, so it's causing more issues. So those are just all things that we have to take into consideration when we're looking at this. So imagine walking uphill in your own house.
Yeah.
Let's see here. More of the floor joist. All right. Do we have one for the upstairs walk that we did?
Yeah. Yeah, I'm sure we do, because I just followed you guys around the whole time. We'll just move right on to the next clip here, and it'll just go right into where we went next. But this is the one, I think, that next one.
All right.
I don't know why it's not pulling up. We're having some technical difficulties here.
Oh, maybe
There we go.
that.
Let's see if this is the one, though, that you're looking for. You want to go ahead and move upstairs?
Yeah, let's move
Okay.
upstairs.
Yeah.
So
Back up. Here we go. Okay, walking upstairs.
now we're walking up the stairs to look at the movement that has happened in this house from the stuff that we had found in the basement. So what we're looking for are stress cracks in the walls, gaps in between the floor and the baseboards. Are the doors closing properly? Do they not close properly? And let's see.
You're not going to be able to see the actual cracks on the video, but you'll see where the light is pointed and where you're looking at.
Right. And I think actually once we get in this bathroom, we'll be able to, right now I'm looking at the floor joist, and let me pause it here. So, oh, that's blurry. There we go. So this over here from the basement, that is where the floor joists were broken, and somebody had cut through one of them and put plumbing in to put a toilet over here. So they didn't splice it, they didn't box the joists out, they didn't do any of that. So in the long run, you can see where my cursor is, where it's running here, that there is at least a 1/4 inch gap on this side, and it's tight in this corner. And those are things that we're actually looking for to see what kind of movement is. And then let's see if we get a little bit farther, if you can see the cracks. So you can see a little better here that it goes from roughly a quarter to a half-inch gap here, and then it's tight along this side of the wall. And that's telling us what kind of movement has happened.
So, quick question here. What if you're looking at a structure like this and it's just so bad, it's in such poor condition that you wouldn't well, how could you correct that, I guess, is what I'm trying to ask.
So,
Could
and
you, could it be corrected, like say they have a structure that has questionable integrity, could you move forward and correct it and go ahead and do a basement dig out?
yes, we can. So it gets into how much money does the client want to spend? And okay, does the engineer say we need to go in and replace all of the floor joists? Or can we splice onto them? Do we need to splice onto both sides of the floor, the existing floor joists? Do we need to put in another beam, an LVL beam or an I beam to hold the load? So yes, we can do that. It gets into the point of how much money does the client want to spend? And
Okay,
does it make sense to spend that kind of money on repairing a house? Or does it make sense to demolish the house and rebuild a new one?
okay. So would it be safe to say then that if the funding was there, that regardless the condition of the house, that it could be corrected and a basement could theoretically be put under just about any house in
I would say yes.
Okay. Huh. All right. Just out of curiosity, as we're looking at this stuff, I'm
Right.
having some thoughts here.
And then let's see. On these walls, I don't think, okay. So if we go back just a little bit, let me see if I can do this. Right. So as the video is playing, you'll see my flashlight come up this wall and here. So there is a stress crack from the corner of this door that runs directly across. And then in this room, it actually ran across the ceiling. So that's telling me that, and to give you perspective of where this room is, we are right above that last section where all those floor joists were damaged in the basement.
There it goes.
So you can kind of see it here, and then it comes across, and you can kind of see it in the light here. So that's telling me that this house is actually moving, and this is an interior wall of the house. And as we move a little bit farther, you'll be able to see there are some cracking. This here is an exterior wall, and there's cracking that goes across the ceiling, across this wall here, and it actually runs across this whole ceiling, and then it's spidered down on this wall as well. So to give you a little bit more perspective, again, over here when we were standing in the basement, there were the brick in the foundation wall were deteriorating, the tuck pointing were going away, and this is the back corner of the house to give you some perspective of where we're at and what we've seen in the basement. This here is the back exterior wall, and there's actually cracking that comes across here and down across this corner. Right below here was those joists that were rotten. Somebody had tried to repair them, but I don't think it worked. And now I'm looking at the the floor, and somebody had come in, because if you take this cove molding off of the floor, there is a good 3/4 to 1 inch gap in between the the base mold and the floor joist. So their fix was to come in and put that cove molding in to hide that movement in the floor. And you can actually see right here, here's the cove molding. That's the bottom of the baseboard, and there's still a crack above the cove that they couldn't conceal.
Wish we had had that light that day, the floodlight.
Right,
I keep it over here now in the office, so if anybody needs it
right.
for that.
It's our sunlight for dark rooms.
Yeah.
Hi, Thomas.
So,
I
do
see
we have
there.
any questions as of this point?
Yeah, there are currently two more questions. First one is asking, how do you differentiate between foundation settlement cracks and structural deflection and/or wind load induced cracks?
Oh, that's a good question.
So if their foundation,
Foundation or structural cracks?
our wind deflection, did I get that right?
It's between foundation settlement cracks and structural deflection and/or wind load induced cracks.
Huh.
So in this application itself, it looks more of a structural issue, seeing that the brick is deteriorating, the tuck pointing is moving away, and so it's almost it's a case-to-case base on that, because I mean, if you have a concrete foundation compared to this one was a brick foundation, and you had the same thing there, if there's no cracks in the concrete foundation below you, but there's a bunch of movement on the top, that's going to probably tell you that there's something else going on above the foundation than below the foundation.
Huh.
Thank you.
Did that answer your question?
That question is from Douglas. Douglas, if you'd like any more information, please let us know in the questions bar. I'll keep an eye out for that.
Cool.
And the other question that we currently have is also from Douglas. It reads, do you do any soil tests for new footing capacity, hand auger and shear vein test by a geoengineer?
Yes, we do. So by city requirements, before we can do any dig outs or any new build, a soils test has to be done, so we know what we're working with.
All right, that's all I got for today's video. Thank you for joining us. Drop your comments below, and don't forget to support your local small business by subscribing to this channel, and we'll see you again next time.